Hello guys, this is our last video of the course. Can you believe it? We have almost finished, and one of the last topics of the course is an application of the definite integral for physics. And it is basically how to find the work using integral calculus. The most important function or formula that we have to remember is that the work it is equals to the integral of the pressure times the differential of the volume from an initial volume to a final volume. So if we remember this formula, it will be very easy to solve some exercises in which you have to find out the work. Okay, so let's do our first exercise. Exercise number 1 says the volume of a gas is increased from 0.2 to 0.8 cubic meters. Find the work done by the gas if the pressure is a function given by P, which is pressure, is equals to 60 V squared. So first thing we have to remember is the formula of the work, which is equals to the integral from the initial V to final V, or the initial volume, which in this case is 0.2 to 0.8, of the pressure, which is 60 V squared, times the differential of V. By doing the integral of that, that will be 60 V cubed over 3 from 0.2 to 0.8. 60 over 3 is 20, so that will be 20 times 0.8 cube minus 20 times 0.2 cubed. And doing the computations, that is 0.8 cubed times 20, 10.24, and 0.02 cubed times 20 is 0.016. So the final result is 10.08 joules, which is the unit for work. And something that is important to remark is that the work is positive, because the work is done by the gas, so it is an expansion of gas. If it were a compression of gas, the work will be negative. Another type of exercises that can be done using a definite integral and that are related to work is the exercises when you have the pressure volume diagram like this. So what is a pressure volume diagram? It's basically a set of functions in this case that are graphed in a Cartesian plane, in which the x-axis is always the volume and the y-axis is always the pressure. So in this case, if we are asked to obtain the work done, what they are looking or what we want to obtain is the area under the curve. And as we have three different functions, we have to find out first three areas. So first area will be the work done from point A to point B. And as you can see, that is a horizontal line, so the work done in this case it's 0, there is no area. Then we have the area from B to point C. That will be the integral from 1, which is this value, to 7, which is the value in which we have C. The integral from 1 to 7 of the function, that in this case is 6 times the differential of the volume. Okay, let's obtain this integral. The integral of 6 is 6v with volume from 1 to 7. So this will be 6 times 7, 42 minus 6, and that will be 36 joules will be the unit. But, well, it's actually, if you look at you pay attention to the unit on the y-axis, we have that the pressure is given in 1 times 10 to the 5 Pascal. So the unit will be actually 1036 times 10 to the 5 joules. So now we know that this area over here is 36, but we want now the area over here. So that will be the last work, which is the work from Z, which is the work from Z to D, which is the integral from 7 to 10 of the function that in this case is 46 minus 4b over 3 times the differential of b. Let's do this integral. That will be 46 over 3v minus 4 over 3b squared over 2 from 7 to 10. And if we simplify this, we will obtain 46 thirds of b minus 2 thirds of b squared from 7 to 10. So we simplify, we substitute, the upper limit, which is 10, minus 2 thirds of 10 squared, and then we substitute the lower limit, which is 7, 46 thirds times 7 minus 2 times 7 squared over 3. That will be 460 over 3 minus 200 thirds minus 46 times 7, which is 322 thirds minus 7 squared is 49 times 298 thirds. So this will be 407 minus 200, 260. 460 minus 200, and 322 minus 98 is 224 over 3. And finally 260 minus 222, this will be 36 thirds, which is the same as 12 times 10 to the 5 joules. So finally what we have is that we had 36 times 10 to the 5 joules in this side, and we have 12 times 10 to the 5 joules on this other side. So total work will be 36 plus 12 times 10 to the 5 joules, which is the same as 48 times 10 to the 5 joules. And that is the exercise. I hope it's clear. Basically, I think you have already seen this application in physics, but now we can link the knowledge of physics that you already have with the knowledge of calculus and integral calculus. I hope you have understood this video, and now you just have to do the exercises on Schoology. Okay, see you.